So I was saying the union set is just addition of two sets. So in mathematics, when we talk about union, we're simply talking about two sets being added. So when you add two sets, when you say, so when you say A union B, means that you're just combining A and B without repeating the common elements. So as you are combining the two sets, you don't have to repeat the common elements. Okay. So the intersection set is simply just the listing of two common elements. Okay. I mean the common elements. Please send us the recording. Join inlet. Okay, I'm going to record and I'll send the recording to the group. Yeah, but I've added you to the group, Geoffrey. Let me check. Maybe I've sent the link after. Okay.
I joined in late, so I missed out the whole of the first class.
All right. Don't worry. I'm going to send the recording immediately after the lesson.
Yeah, thanks.
All right. You're most welcome. So I was saying, when you talk about the intersection set, we're simply just talking about the common elements. If you have A being equal to 1, 2, 3, 4, and then you also have B, which is equal to 2, 3, 5. So if this is what you have, they ask you to list A intersection B. A intersection B is just simply the common elements. You have one there, we don't have one there. We have 2 there, we also have 2 there. So 2 is common. We also have 3 here and there. So 3 is also common, but we don't have 4. We don't have 4 there. We have 5. So we have 4 there. We don't have 4 there. We have 5 there. We don't have 5 in set A. So these are the only common elements that we have. Hence, the intersection set of A and B is simply just 2 and 3. It only contains 2 and 3. So that's what it means when you talk about intersection. Okay, so this is what I'm just talking about. This is what I'm just talking about. Okay. We just go back a bit. We need to talk about something on the previous page. Okay. Okay, so on this page, I wanted to talk about the shading. Yeah. So when we talk about the union set, it's simply just shading everything, shading the two sets that we've been given, meaning you are talking about all the elements that you've been given in, yeah, that you've been given in both A and B. And then when we talk about A intersection B, A intersection B is simply just a common part, meaning in A and in B, when you look at the two common elements in both A and B, the common part is just simply this part which is shaded here, which is in both A and in B. Okay. So let's move on. Okay, so let's talk about the complement. So the complement of a set, if for instance you have set A, you have set A. So the complement of a set, if for instance you have set A, let me start by listing the universal set. You have the universal set which has been given to be maybe 1, 2, you have 3, you have 4. If this is a universal set, and then set A has been given to be maybe 2 and 3. So if they ask you to find a complement is just listing the elements that are not in A, but they are present in the universal set. So the elements that are not in A, but they are present in the universal set are simply just 1, 2 is also in A, 3 is also in A, and 4 there. So A complement is just simply listing the number, the elements that are in A, but the elements that are not in A, but they are present in the universal set. Okay. So let's quickly move on. Okay. So this is what I'm just explaining. So there's also another important thing that we need to know, which is the set difference. Okay, it has gone back. Let me just go back to where I was. Yeah, other important thing that you need to, okay, so let me talk about the shading here. So if you have, this is the universal set, meaning the set of everything that you've been given in both sets A and B and outside set A and B. So if they ask you to shade A complement, it's just elements that are not part of A, but they are in the universal set. This is B complement, this is A complement. Okay, so this is just an example here, which you can go through when I send the slide. Okay, so when you talk about the set difference, so the set difference is simply just, it's also called the relative complement. The set difference of A and B is denoted by A minus B. So set difference, when you talk about difference in mathematics, we are simply talking about a minus sign. Whenever you hear the difference between two things, it's simply the subtraction between two things. Yeah. The minus sign is the one that we refer to as the difference in mathematics. So it is denoted by A minus B. So this one is just a set of elements in A that are not in B. So if you've been given the universal set and set A, you've also been given set B. So A minus B is simply just writing the elements that are in A, but not in B. The elements that are in A, but not in B, that is the set difference. So in set Builder notation, the set difference is simply just given by A minus B, and then which is just the same as X is a member of the universal set, where X is a member of A, but X is not a member of B. And then in set notation, you can just say A intersection B complement. Yeah, so it is simply just A intersection B complement. That's the set difference. Okay, in the Venn diagram notation, the set difference is just this one here. You are listing the elements that are in A, but not in B. The elements that are in A, but not in B. That's the set difference. Okay. All right, so the symmetric difference of two sets. Let's take a look at this example. Let A and B be two sets. The symmetric difference of two sets A and B is given by A, a triangle in between, and then B. But this one, I don't think it's part of your syllabus. So let me just skip it. I didn't see it in your, let's just look at the De Morgan's laws. Okay, so De Morgan's laws, okay, for the sake of just knowing, when we say A, and then you see this symbol in between, and then you write B there. This one in set Builder notation can just be written as X, such that X is a member of A minus B union B minus A, which is just the same as A union B minus A intersection B. So if they ask you to find, A and then a triangle in between B there, you simply just say this one. You can just say A union B, and then you do this, you put brackets, and then you find the set difference between A union B and A intersection B. Yeah, so that is what it means. So you first find A union B, and then you say minus A intersection B. So in other words, if you've been given the universal set, you list the elements that are in A union B, but not in A intersection B. Okay, so you don't have to stress understanding this, because I didn't see it in your handout. So It's just the sake of knowledge. Okay, so let's take a look at the De Morgan's laws. So these are some of the De Morgan's laws that you need to understand. When you have A minus B intersection C, this can also be written as A minus B intersection. Okay, here, this is just the distributive law. That's what I can just call it. Okay, that is what it is. So when you have A, let me use intersection and union before we use the set difference. When you have A intersection, B union C, if you have something like this can be written as you take this A intersection, you pair it with B. So we're going to say A intersection, we pair it with B, then we put them in brackets, and then we write this symbol in between. And then from there, we pair A intersection with C. A intersection with C, we pair it with C. So that is how you write it. So same applies if you have the set difference. When you have A minus, then you have B union C. So this one can just be written as you take this A minus, this A and the minus, you pair it with B. So you say A minus, you pair it with B, you put them in brackets, then you say union, you put the union in between there, and then you open the brackets, A minus, you pair it with C. Yeah, so I said if they give you assignments, you can send them over so that you can be discussing some of the difficult questions in your assignments. Then I'll be leaving those simple ones for you. But of course, that's not it's not I'm not saying you shouldn't be answering them, or if you want you can solve it, and then before you submit it you send it to me first. I check through. Yeah, if that is okay for you, for the sake of the exam, you can solve it on your own, send it through to me, I check it through, and then you submit it. Yeah, but I assure you most of you will be getting 100% in your assignments. Okay, so you just have to prepare enough for your exams. Assignments, don't worry. Okay, so let us also look at this part, which is the complement. So the first part here, the first part here is the one that I've explained there, which is also similar to this one. The only thing that has changed is the symbol in between. And I think there was a mistake here. A minus B and then A minus C. Yeah, there was a mistake. This was supposed to be union here. And then here, this was supposed to be intersection. There was a mistake. So when forwarding this, I'll change that. Okay, so let's look at B union C complement. So if you have, let me use A and B. If you have A intersection B, and then in brackets, and then there's a complement outside, this one, when you distribute the complement in the brackets, it means that the symbol there in between will change. So when you distribute the complement, we put the complement on A, we also put the complement on B. It means that the symbol, if you have intersection there, this will just become union. So same applies to the other form. When you have A union B, and then you have complement there, you're going to have, when you distribute the complement, this will become A complement intersection B complement. And then the other thing that you need to understand there is that the opposite is also correct. I don't know what has happened. There's someone who's calling me on WhatsApp. Okay, let me just do this and then we start it over. Okay. So let me just pick up this call. Okay, let's continue. All right. So just tell the people to text me on WhatsApp. These are calling me. And if there are also people that have not yet joined the group, or if there are also people that do not know about this program, you can tell them. Yeah, you can tell them. Okay, so let's look at the other laws. So we looked at the De Morgan's laws, which are here. We looked at these laws here, this one, that one, this one, and that one. So I summarized by saying A intersection, oh, sorry, A complement, not intersection. So A complement intersection B complement can also be written as A union B and then the complement outside. So I've just switched them. I've just started from this side going to this other part. So you can also say A intersection B, then in brackets complement. This one can be written as A complement union B complement. So that is what it means. Okay. So, okay. All right. He's saying I send him the link. Okay. Let me just get it from the group. All right. So this is what I was talking about. Let's look at the other laws, the other set laws. So you also need to understand that the complement of the universal set is an empty set. So the complement of the universal set is simply an empty set. Why do we say it's an empty set? Imagine you have a universal set, U, and then you have sets there, A and B. Then we say, list the number of elements that are not in this set. List the number of elements that are not in the universal set. It's simply the sets which are outside the universal set, and we don't have anything apart from what is in the universal set, meaning it's just an empty set. Same applies when we say the complement of, when we say the complement of the empty set. So the complement of an empty set is simply just the universal set. So the complement of a universal set gives you an empty set. The complement of an empty set will give you a universal set. And then A intersection A will simply just give you A. So A intersection A simply means that you find common elements that are both in A and in A. So if you have A, maybe if you have A is equal to 1, 2, 3. So they ask you to find the common elements between A and another A, which is the same, 1, 2, 3. Then they ask you to find the common elements, which is in A and in A. So A intersection A will simply just be 1, 2, 3. The common elements that are in A and in another A are simply just 1, 2, 3, which is just equivalent to A. Hence, A intersection A is simply just A. Okay. So A intersection A complement is simply just an empty set. How is it like that? Look at this. You have a universal set, and then you have set A there. Then we're saying A intersection A complement is an empty set. So let's find the common elements between what is in A and what is not in A. So what is not in A is simply what is in the universal set, but not in A. So we find the common element between what is not in A and what is in A. So the common element between what is in A and what is not in A is simply just 0. Oh, sorry, simply just an empty set. Yeah, it's a 0 across the 0. That's why I'm sure I made a mistake by saying 0. Okay, so if you have set A like this one, and then they ask you to find the common elements between set A and what is not in set A, it means that, the answer is simply just an empty set. And then if they say A union A, the answer is still A. So A intersection A and A union A, the answer is still A. And then you also have A intersection the union set, the universal set. So A intersection universal set, the answer is still A. Why? Because A is a subset of the universal set. Okay. And then same applies. A complement intersection A complement will still give you A complement. And then A union A complement is simply just the universal set. The you can take time to prove this using the Venn diagrams. For instance, what I was doing here. So if you have you have set A there, and then this is the universal set. They ask you to find the union between A and A complement. So you have A there, and then you find the union between A and A complement. A complement is simply what is not in A. So you find that you add the two sets. What is in A, you add it with what is not in A. You simply just give you the universal set. All right, so let's proceed. So the other set laws that we can discuss are simply just I don't know. Let me just go to the last page. Okay. The other set laws that we can also talk about are commutative law. So the sets are also part of mathematics, so we expect them to obey all the other laws of mathematics, like commutative law, meaning the arrangement, whether you start with A this side and end with B, or you start with or you start with B and end with A, you still get the same answer. So A intersection B is equal to B intersection A. Same applies to A union B. This is just the same as B union A. So this is just a commutative law. Commutative law is also important on binary operations. So we're going to look at that when we reach binary operations. I don't know why it's doing this. Okay. So we also look at the associative law. So the associative law talks about the arrangement of brackets. So if you want, you can start with the brackets, putting the brackets on B and C, or if you want, you can start by putting the brackets on A and B. When you follow BODMAS, according to BODMAS, which is just brackets of division, multiplication, and subtraction. So multiplication, addition, and subtraction. So according to BODMAS, it means that when working out any mathematical operation, you have to start with what is in the brackets, because brackets are the ones that are starting in BODMAS. So if you start with B intersection C, and then you come and intersect it with A, it's just the same as starting with A intersection B, and then you come and intersect it with C. So that is what we call the associative law. Then distributive law is the one that I even gave as an example on A minus B intersection C on the previous, on that other slide. That was the distributive law, where you just take this A intersection, you combine it with B, it gives you A intersection B, and then A intersection, you combine it with C to give you A intersection C. And of course, this symbol you're seeing here is the one that you use in between there. Same applies to this. A union, you combine it with B, you get A union B, then you get this symbol, you write it in between there, then you say A union again, you combine it with C there. So you have A union C. And then the De Morgan's laws of complement, sometimes they are called the complement laws. So these are just what I explained on that same slide, where you say A union B complement. So sometimes complement can be represented by this symbol, or sometimes they can say A union B, and then they write a C there. They can either put a C or just an apostrophe. Yeah. So yes, I'm not good at English. I may have made a mistake. I don't know if this is truly an apostrophe. Yeah, okay, so can either be represented by that or a C. So that is how you can write it. So remember what I said? I said when you distribute the complement here, the sign in between will change. So this will be this A union B will become A complement intersection B. Same applies to A intersection B, it will change to A complement union B complement. The other way is also okay, the opposite, meaning you can also start from this side going this other side, where you say A complement union B complement is equal to A intersection B complement. Yeah, meaning you still also have to change the sign when you factorize the complement. Okay, so we have reached the end of the slide. I'm going to send an exercise. If you have any questions, feel free to ask. If you have any questions, feel free to ask. Otherwise, this is the end of the slide. Okay. If you have any questions, feel free to ask.
So are you going to send? Are you going to send the records on the same platform?
Yes, I'm going to send the records on WhatsApp, but I also recommend that you can download Telegram, because WhatsApp doesn't keep information, but Telegram, even if you change your phone today, the day you rejoin Telegram using the same number, you find everything. Meaning, if you, in case you change the phone, maybe 2 months from now, you still have the same data on Telegram. But for WhatsApp, you lose everything immediately you change your phone. So maybe let's also download Telegram. I'll create a Telegram group where we'll all be requested to join. I'll just send the link in the group and then everyone will join the Telegram group.
Okay.
Yes, so if you have questions, please feel free to ask. Okay, so you don't have questions? I'll end here and I'll end the meeting. I'll send the recorded sessions to the group together with the slide. Thank you very much for your attention.
Then the exercise, are you going to send it on the same platform?
Yes,
Thank you. Goodbye.
Hello? I'll send it on WhatsApp.
Hello.
Yes.
The exercise, are you going to send it on the platform?
Yes, I'll send it in the group.
I thought maybe you wait until we download the Telegram.
Or I should wait?
No, you can send
No,
it.
I'll send it. I'll send it. So the way it is that I'll send everything that will be on WhatsApp will also be on Telegram. So that in case you change your phone or you change the line,
Yeah.
you find them.
Yeah, just send both.
All right. All right, Sydney Mutuda. You have a question?
Thank you. Not really a question. I think I was just trying to inform the group that probably we quickly download the Telegram. I think some of us have had the Telegram already.
Okay.
Probably to the other team members, yeah, we quickly download, because I'm also told that with Telegram you can actually send big files.
Yes.
As opposed to WhatsApp.
Yes, yes, that's
so just an encouragement to the team members to quickly, they just go to Google Play and then download.
Okay.
Yeah. Otherwise, thanks for the lecture. I think some of us are now getting to understand.
Yeah, it's making sense now.